Hi, welcome to part 10 of the video series about work and energy. In the previous video, we have defined the work-energy theorem. In this video, we start to solve some examples to see this theorem in action. In the first example, the driver of a 1000 kg car traveling at a speed of 20 meters per second applies the car's brakes and stops when he sees a red light. We need to calculate the net work done on the car. If a question involves velocities and net work of an object, most probably the solution lies in work-energy theorem. Let's start solution by writing down the formula of this theorem. Net work done on an object is equal to the change in the kinetic energy of the object, which is the final kinetic energy minus initial kinetic energy. Kinetic energy of an object is 1/2 times mass times square of velocity. Mass of the car is 1000 kilograms. Final velocity is 0 as the car stops after applying the brakes. And initial velocity is 20 meters per second. The net work done on the object is equal to minus 200,000 joules. We can notice that the net work has a negative value, while its velocity and depending on the velocity, its kinetic energy decreases. The outcome of this observation is that if the net work done on an object is negative, the kinetic energy of the object decreases. Otherwise, if the net work done on an object is positive, the kinetic energy of the object increases. In the second example, a 4 kg block is moving at 10 meters per second. A net force of 20 newtons is constantly applied on the block in the direction of its movement until it has moved 42 meters. What is the final velocity of the block? Again, we start the solution by writing down the formula of work-energy theorem. The net work is equal to the change in the kinetic energy of the object, final kinetic energy minus the initial one. As we learned in part 5 of this video series, the net work can be calculated as the net force multiplied by the displacement of the object and cosine of the angle between these two. On the other side, the kinetic energy is 1/2 times mass times square of velocity. The net force is 20 newtons, displacement is 42 meters, and the angle between the two is 0 degrees, as the net force and the displacement are in the same direction. Mass of the object is 4 kilograms. Initial velocity is 10 meters per second. Final velocity of the object is 22.8 meters per second. In the next example, a man is driving a car with the mass of 2000 kgs at a speed of 30 meters per second on a highway. Suddenly, he puts on the brakes to avoid an accident. After the brakes are applied, a constant kinetic friction force of magnitude of 5000 newtons acts on the car. What is the minimum distance from the car ahead at which the brakes should be applied to avoid an accident? We repeat the first two steps from the previous questions by writing down the work-energy theorem. Before proceeding with the formula, let's draw free body diagram to find out which forces will do work on the car. Force of gravity is acting downwards, while the normal force is acting upwards. And there is the friction force acting in opposite direction to the motion. We can ignore work done by the force of gravity and the normal force, as they act perpendicular to the displacement, thus doing zero work. The only force doing work on the object is the force of friction. Therefore, we can express the net work as the friction force multiplied by the displacement and cosine theta. On the other side, kinetic energy is equal to 1/2 times mass times square of velocity. Friction force is 5000 newtons. We don't know the amount of displacement, and the angle between the friction force and the displacement is 180 degrees, as they are in opposite direction. Mass of the car is 2000 kilograms. Final velocity is 0, as To avoid the accident, the car has to stop. Initial velocity is 30 meters per second. As a result, the minimum distance to avoid the accident is 180 meters. In this video, we solved 3 examples to see the work energy theorem in action. In the next video, we are going to solve one more example to understand how to use the theorem on an object sliding on an incline. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.